In this video, I'm going to attempt to introduce inverse trig functions. In order to do that, we need to just review quickly our understanding of inverse functions. Let's start with a basic graph of y equals x squared. So here's my parabola. Whoa, that's not a parabola. Let's try again. Okay, this is going to be as good as it gets for now. So there's my parabola, y equals x squared. The inverse of y equals x squared, we reverse the inputs and outputs, and then we solve for y. So we would square root both sides. When we square root both sides, we have a plus or minus. So the inverse of y equals x squared is y inverse equals plus or minus the square root of x. Well, the positive square root of x, we know from our parent functions, looks like this. And the negative square root of x, do that in purple, our negative square root of x reflects over the x-axis. So it looks like that. So this green and purple parabola on its side would be the inverse of y equals x squared. We know from a long time ago, I would say probably back in Algebra 2, when we learned about inverse, or when we learned about functions, so way back maybe even in Algebra 1, functions have to pass the vertical line test. Well, if I'm looking at my parabola, just the red parabola passes the vertical line test. That would make the parabola a function. So my y equals x squared is a function. However, when I look at its inverse fails the vertical line test almost right away. It crosses the green and purple parabola, crosses through a vertical line twice. Therefore, it does not pass the vertical line test. So this function is not, or this equation is not a function. In order for our parabola, y equals x squared, to have an inverse function, it already has an inverse. Its inverse is not a function. In order for y equals x squared to have an inverse function, we need to limit the domain. So we've talked about this before. We're going to limit the domain to just half the parabola. So we're getting all of the range from 0 to infinity, but instead of including both sides of the parabola, we're going to limit the domain so that y equals x squared passes the horizontal line test. If I look at the red parabola as a whole, it does not pass the horizontal line test, which leads to its inverse not passing the vertical line test. So if we want the inverse to pass the vertical line test, the original function has to pass the horizontal line test. So if we limit the domain to just this green highlighted section, that green highlighted section is going to pass the horizontal line test. So when I limit y equals x squared to y equals x squared, where x is greater than or equal to 0, x is greater than or equal to 0, then I'm looking at just this highlighted section. When I do that, just this highlighted yellow section ends up being its inverse. And in that case, its inverse would pass the vertical line test, making it an inverse function. So we've talked about this before. Now what we want to do is we want to apply this to our trig functions. So I'm going to come back here and start talking about y equals the sine of x. So I want you to think about y equals the sine of x. We know that it continues left and right forever. So don't look at all this stuff right here. Let's look at y equals the sine of x. So y equals the sine of x continues left and right forever. So here's negative infinity on the left and positive infinity on the right. That's where this negative infinity is coming from and this positive infinity. X can be anything in between negative infinity and positive infinity. Now we talked about our range. Our range goes as high as positive 1 and as low as negative 1. So that's all these inequalities mean, is our domain can be anything from negative infinity to positive infinity, and our range goes from negative 1 to positive 1. Now when I reverse the inputs and outputs to get my inverse function, so y equals arc sine of x is the inverse of sine. And you saw me on the other page write y inverse like that. That's the notation that we're going to also use to show the inverse function. So y equals the inverse sine of x. It can be written y equals arc sine of x. That is the same thing as y equals the inverse sine of x. What happens when we reverse our inputs and outputs is the range of the original function becomes the domain. So that's where this is coming from. So let me just do this in blue. So this range is going to become the domain of the inverse sine. And normally the domain becomes the range. However, if you look at this function, it's not going to pass the horizontal line test. So in order to have an inverse function, we need to limit the domain. So what we do is we take the lowest point to the highest point in a continuous move. So we want a continuous function. We don't want to piece it together, and we don't want to duplicate y values. So we cannot duplicate any y values. So the lowest point would be y equals negative 1. The highest point would be y equals positive 1. So we're going to look at just this green section now. That's going to be the section that's going to give us all of our outputs, or all of our outputs of the original function from negative 1 to positive 1 without duplicating them. However, what would the domain be? The domain no longer goes from negative infinity to positive infinity. It goes from negative pi over 2 to positive pi over 2. So that's what becomes the inverse function's range. So that's where this is coming from. It's coming from that limited domain. So because we have to limit the domain of y equals the sine of x, instead of going from negative infinity to positive infinity, it goes from negative pi over 2 to positive pi over 2. And the reason we chose negative pi over 2 to positive pi over 2 is because it allowed us to go from the lowest y value to the highest y value continuously without having to pick up our pencil and move it to another section, without having to duplicate y values, because you cannot duplicate y values, otherwise the function is not one-to-one. Once we limited the domain, that became the new range of the inverse function. So what you want to do is you're going to want to make sure that you know the domain and range of the original function. So flashcards, if I was making a flashcard, you would have y equals the sine of x, and you would put domain. And on the flip side, you would put negative infinity to positive infinity. Y equals the sine of x, range. And on the back side, you would put, using brackets, -1 to +1. Now using the inverse function, y equals the inverse sine of x. That domain will be -1 to +1, and the range will be from -π/2 to +π/2. Okay, so let's take a look at cosine. Cosine is going to work the same way. Because the domain of cosine goes from -infinity to +infinity, we want to limit the domain to include the highest y value to the lowest y value. So we want that domain to include this section right here. So I'm going to limit the domain to go from 0 to pi. When I do that, its inverse function, which is y equals arc cosine of x, or I can write it y equals the inverse cosine of x, this domain, this limited domain that allows us to have a one-to-one function, becomes the new range, and the range becomes the new domain. And again, I would make flashcards of this. What's important for you to know is that when we say, for instance, on y equals inverse sine of x, when we say the outputs are -π/2 to π/2, we're talking about -π/2 to +π/2. We're talking about quadrants 1 and 4. So our angles need to fall between -π/2 to π/2. And I'm going to explain this a little bit more once I get through all the trig functions. So here's our cosine. Cosine's outputs, their angles, will go from 0 to pi. So all the allowable outputs for arc cosine are going to fall in quadrants 1 and 2 between 0 and pi. Now tangent is very interesting. We worked with tangent just recently. Tangent has asymptotes at -π/2 and +π/2. So this function is naturally between -π/2 and +π/2. It's naturally one-to-one. So we don't need to limit this domain. So the domain is going to go from -π/2 to π/2 for our tangent function, and our outputs go from negative infinity on the y-axis all the way to positive infinity on the x-axis. Now when we do our inverse function for tangent, we can write y equals arctangent of x, or y equals inverse tangent of x, or inverse tangent of x. And again, when you have inverse functions, the domain of the original function becomes the range of the inverse, and the range becomes the domain. So what does this all mean? Well, let's make sure that we understand what it means to say y equals the sine of x. When I say y equals the sine of x, that means a ratio is equal to the sine of an angle. And this is true when I say y equals cosine of x, the same thing. A ratio is equal to the cosine of an angle. I'm sure you are getting a kick out of that puppy barking in the background. And I can do this for all of the functions. Y equals cosecant of x, y equals secant of x, y equals tangent of x, y equals cotangent of x. But you get the idea. The sine of an angle is equal to a ratio. The cosine of an angle is equal to a ratio. When I reverse the inputs and outputs, and I change this to the inverse function for sine, my outputs are no longer ratios. So these outputs have now become the input of the inverse, and the input becomes the output. So I'm going to have an angle is equal to the inverse sine of some ratio. So we're going to be working with problems where we're putting fractions in that are just ratios, and we're going to be getting out angles. So when I'm looking for my output for sine, my output for sine is going to fall between negative pi over 2 to pi over 2. When I do cosine and I have y equals arc cosine of x, or y equals inverse cosine of x, or I think that's how we say it. I write cosine with the -1 for the inverse, but many times I just say y equals arc cosine of x because it's easier to say. Y equals the arc cosine of x. I'm going to again have the angle is equal to the arc cosine of some ratio. And the angles that are the outputs that are allowed for the angles for cosine are between 0 and pi. So this is extremely important right here. If there's nothing else that you get out of this, this part right here is going to explain or help you do the math. And you need to know this. If you don't quite understand it right now, that's okay. The understanding is going to come. You could go back and look at what I did with limiting the domain to find out where these are coming from. But you've got to know that for arc cosine, my outputs are between 0 and pi. And for arc sine, my outputs are between negative pi over 2 and pi over 2. And I can do the same for arc tangent. And I'm going to take the opportunity to do this for arc tangent. Y equals the tangent of x means that my ratio is equal to the tangent of some angle. When I do y equals arc tangent, and I just really wanted to write the letters arc there to show you what it looks like when I say arc tangent. The angles become the output and the ratio becomes the input. So I have the angle equals the arctangent of the ratio. And our angles for arctangent are just like sine. They fall between negative pi over 2 and pi over 2. So everything that I've highlighted here is super important for you to know. This y being between negative pi over 2 and pi over 2 goes with tangent, and it goes with arc sine. When we're talking about arc cosine, we're talking about y being between 0 and pi. So now what I want you to do is I'd like you, these are the inverse function graphs. I'd like you to try and figure out which one is y equals arctangent. So which one is y equals arctangent of x? Which one is arc cosine of x? And which one is arc sine of x? And you might want to press pause while you talk about this or try and figure it out. And when you're ready to check your answer, go ahead and press play. Okay, this is how it would fall. The reason this is arc sine is because, remember, our angles were our input and our ratio was our output for y equals the sine of x. But when we do the arc sine of x, our ratio is now on the y-axis. I'm sorry, the ratio is now on the x-axis, and the angle theta is on the y-axis. So the fact that we're going down to negative pi over 2 and up to pi over 2 means this has to be either tangent, arctangent, or arc sine. The reason it's arc sine is because arc sine also has a limited domain. And the domain, the ratios that you can put in for sine, go from -1 to +1. -1 to +1. So now when we understand that and we look at this graph right here, we know that its inputs go from -1 to +1, but its outputs go from 0 to pi. That puts us with arc cosine, and then arctangent, although its outputs go from negative pi over 2 to pi over 2, its inputs are endless. So it goes from -infinity to +infinity. Now, that's just a slight introduction to our inverse functions. Make sure that you've got this so you kind of have a good feeling about this. And then in the next video, we will start to do some problems.